Good afternoon, everyone. Today we will be talking about silicon nitride ceramics, and what that is, how it is manufactured, and what products are made with these ceramics. So what is silicon nitride? Well, it is in the name. It is made up of silicon and nitrogen atoms at a ratio of 3 silicon atoms to 4 nitrogen atoms, or a nitride. This ceramic material is very hard, resistant to wear and tear, has a high thermal shock resistance, and does not easily corrode as metals tend to do. This makes it very versatile and widely used in many different things in the world and some things that you might use every day. This includes the fields of aerospace, automotive, electronic manufacturing, and the medical devices. So to make this material you are going to start with getting silicon powder, which is made by first mining quartz, a natural crystal, and mixing it with a carbon source such as coke or coal and heating the mixture to refine it. The result is molten silicon with a carbon monoxide gas. This block of silicon is then broken down into powder, which is then heated to 1400 degrees Celsius, and the nitrogen gas is introduced into the mix to combine with it, creating this silicon nitride powder. This powder is now ready to be manufactured into a product. Also, depending on what you are going to make, some additive might be included to help in the sintering process. If we were going to make a ceramic bearing ball out of silicon nitride, we would start with pressing the powder into a preformed spherical shape. Take that part to be then sintered with a hot isostatic pressing. After that, the ball is then inspected for imperfections and put through a grinding process with diamond grinding tools because of the high hardness of the product. Some manufacturers also use chemical mechanical polishing to get that mirror-like finish to the object. This process can take months depending on how precise and good quality the manufacturer wants to make their product. One company claimed that their silicon nitride ceramic bearings are way better than steel. They claim it is 400% smoother, 128% harder, and 50% lighter. Now that is without a doubt a better solution to steel bearings. Another thing that is made with silicon nitride are medical-grade implants. This involves mixing the silicon nitride powder into a slurry that is then used to form the desired shape. Most popular method of doing this is using the laser-induced slip casting, which is an additive manufacturing technique that combines the principles of slip casting with a laser to build objects layer by layer. The object is created as a green body part, but it is still extremely fragile in this state. It is then placed in a high-temperature furnace to go through the process of debinding and sintering. This process removes binding aggregates and solidifies the silicon nitride, making it extremely rigid and strong. After the sintering process is complete, the part is then machined to its final dimensions. Using high-power lasers, the part is then engraved with different surface textures for improved bioactivity or other functional properties. Then finally it is inspected using various non-destructive evaluation methods. Other things that are made with silicon nitride are cutting tools. This is by pressing it into form the desired shape from a powder mixture of silicon nitride, and some additives depending on what you are making it for, like adding magnesia to aid in the sintering process and improve mechanical strength. Once this mixture is formed, it is called the green body, and then can do some initial shaping while the material is still soft. After that, the part is sent to the furnace with a high-pressure nitrogen atmosphere, a process called gas pressure sintering. This process has high pressure, which helps to prevent the evaporation of silicon and nitrogen. While being in this high temperature, it promotes the densification of the part, where the powder particles fuse together to form a solid, strong ceramic part. So why do they make these parts? Well, the part is super efficient at cutting. It has a good wear resistance, so it can be used to process high hard materials that are normally very difficult to process by normal traditional tools. Since it has such high durability, lives several, or even a dozen times higher than traditional metal tools, it reduces the time spent changing out blades and ensures more uniformity of the piece you are working on. The silicon nitride ceramic blade also has less friction when cutting a part. This makes it difficult for the piece you are working on to stick to the blade, and the roughness of your cut is going to be very low. These very precise, useful, and save a lot of time, and are preferred over carbide cutting tools because of their hardness, strength, and thermal resistance. Another thing that silicon nitride ceramics are used for is automotive parts. Some examples of parts made with this are turbochargers, rocker arm pads, glow plugs, and exhaust gas control valves. Making all these parts means having some that are made the same way, but many are made with different methods, which include hot isostatic pressing, gas pressure sintering, additive manufacturing, sintering, and finally injection molding, which I will talk more about because we have not covered that yet. For injection molding, the silicon nitride powder is mixed with alumina and yttrium oxide to get the properties needed for the part. Then you form your feedstock, which is a mixture of organic additive needed like your binders, plasticizers, dispersants, and lubricants. Once that is made, mixing them but injecting them into a heated mold. At this point it has formed the green part, and is subsequently heated to burn off the binder, and finally sintered to a dense final component. So overall, silicon nitride ceramics are manufactured in numerous different ways, and we have learned the ceramic material is very hard, resistant to wear, tear, has a high thermal shock resistance, and does not corrode as easily as metals do. This makes silicon nitride ceramics very versatile and used widely in many different fields of manufacturing products for the automotive and medical industry. Thank you for your time.